Uh, we are talking about properties of indifferent curve. Yeah. So in the latest video, yeah, we discuss about properties of ICs. First, ICs are downward sloping. Second, there are thousands of indifferent curves in the map. Third, the higher the indifferent curve towards the northeast direction generate more satisfaction level to this guy. The fourth proof in the class, indifferent curve from a person's preference, let's say Mr. A, cannot cross. We prove this. And the last one, indifferent curves look like a sen mi, thin line, not the sen yai, not kway chap as well. You will see here soon. We will utilize the same technique to prove the technique that we use to prove why IC cannot cross. Yeah. The technique that we use to prove, we call proof by contradiction. So let's use this technique again here. But I will just only start a little bit for you and you continue to think about this later on. Yeah. In the two goods example, good X and good Y. This property said indifferent curves are thin line. Okay. So we want to prove by contradiction. What does that mean? Let's challenge this statement. Let's make a thick line and see what's wrong with it. Yeah. Let's have a thick IC and see what went wrong. That's called proof by contradiction. Do something against the statement here. If something wrong happens, then you should believe in this statement. You should respect this statement. Yeah. Let's have a thick one. Okay. Okay, we generate a thick IC. Let's bring two basket to have a look. So basket A and basket B, both baskets live in this indifferent curve, stay in this indifferent curve. Yeah. A contains X1, Y1 units. B contains X2 and Y2 units. Yeah. There are two persons come to look at this diagram, Mr. A or student A and student B. Let's start with student A. Student A argued like this: hey, I see that both baskets are on the same indifferent curve. A and B are on the same indifferent curve. So Mr. A said, then the conclusion that he got is basket A and basket B must generate the same happiness level. Yeah. Okay. Nothing wrong about what he said. It's true. Since two baskets are on the same indifferent curve, we already said if baskets are on the same curve, it must give the same happiness level. A and B are indifferent. This symbol, indifferent. Statement number one. His friend come to look as well. Student B come to look at this. Wait a minute, he said. He observed that B contains more of X and Y. B contains more of pizza and Pepsi compared to A. Then B continued to argue, buy more is preferred to less. The basket that contains more of X and more of Y must generate higher satisfaction level to the other basket, which has lower amount of X and Y. So Mr. B conclude, basket B must be preferred to basket A. They are going to fight. The two statements come from the same picture, but the two statements cannot be correct at the same time. This is a contradiction. Why we got this contradiction? Because it's because of this picture. Make these two people fight. Yeah. Only this or this, only one is true. Cannot be true both. Yeah. We call this as contradiction, which emerge when we allow for a tick indifferent curve. Then to avoid this contradiction, we should not allow to have this tick one. IC must be a thin line. Or what I said, you should write it down by yourself by just look at the previous proof. Yeah. I'm not going to write it down again. Yeah. And this kind. Yeah. Or you can go back home to listen to this again and write it down. Yeah. The argument here to prove that indifferent curve must not be thick. Yeah. Okay. We finished property of indifferent curve already. We are still on this tracker number 2. Yeah. Room number 1, room number 2, room number 3. We are about to leave room number 1 and enter room number 2 soon. Now, slope of indifferent curve. Yeah. As your friend remind you, indifferent curve is just a collection of baskets that generate the same satisfaction level. Let me modify this picture first. Let's call this A, basket B, basket C, basket D then. Can you identify amount of the two goods in each basket first then by yourself? I will do mine. Yeah. No need to look at my writing. You can do it. Yeah. Basket D. Okay. Good X, pizza. Good Y, Pepsi. Yep. Okay. Let's start at basket A. Basket A, this person has plenty of good wine, Pepsi, and a few slices of pizza. He has more of good wine relative to good eggs. You can notice this. Yeah. Then he is not thirsty. He is hungry when he stay here. And then we ask him, hey, if you want to get a pizza, a slide, how many Pepsi you want to trade with, exchange with? And this guy said, he willing to give up 6 units of good wine. Okay, now we are going to compute this, yeah. This guy said, I'm willing to give up 6 cans of Pepsi in exchange for +1 slice of pizza, +1. So that's the rate that he willing to trade good wine for good eggs. At this moment, when he is quite hungry, he value this slide very much. How do we know? Look at the number of Pepsi he want to sacrifice for it. He must be quite hungry to death. Yeah. Keep this in mind. We interview him another question when he, let's say now he has a point C. Hey, mister, if you want to trade Pepsi for pizza, how many units of good wine Pepsi you want to trade with 1 more slice of pizza? He said, oh, I'm quite full already. Look, 6 units of pizza already. If he would want to trade, he willing to give up, check delta y over delta x. He willing to give up -1 y for +1 x. Then the rate that he willing to trade y for x become 1 unit. That's quite makes sense, yeah. He doesn't value this piece that much anymore compared to this one, yeah. When he almost full, his valuation toward this piece is quite relatively low. Yeah. Makes sense. We call this, if you watch the video, we talk about this already. Marginal rate of substitution, MRS. Let's put into this next slide then. This term is quite important, yeah. Marginal rate of substitution, MRS, XY. Change in amount of good Y divided by change in amount of good X. To keep utility constant. Has a little bit more on this, such that this index measures how this guy willing to exchange one good Pepsi for pizza. so that or such that his utility remain unchanged. This part, you may not have a clear idea about this phrase. I will explain this part. Now, I think you are quite clear about this delta y over delta x, but I add something more here that we will discuss it, such that utility remains the same, remain unchanged, remain fixed. Okay. Ready? Let's try to understand this extra phrase here, such that utility remain the same. Look at this again. Now, let me delete this for a while and give you a different story. Okay. We still use this recipe to compute MRS, but we change the story a little bit. The first story that you already know, we travel from top to the bottom. We ask him question, hey, how many Pepsi you want to trade with pizza? This is a question to him. Now we change a little bit. Now we're going to travel upward and see the meaning of this. Suppose this guy is at point D, 7,3, 7 units of X, 3 units of good Y. We ask him this question. If we ask him now, hey, if I steal pizza from you, minus, yeah. If I steal pizza from you, you're going to feel very sad that he will come to this spot, yeah. Which you can imagine that actually there is an indifferent curve here, yeah. Different curve here. He fall to the lower indifferent curve if we steal pizza from him. And then we ask him, how many of Pepsi you want to be compensated so that your utility resume or get back to the same happiness level. He said, give me 1 can of Pepsi. So it's going to be like this. We steal good X and we compensate with 1 Y. Yeah. Yeah. You see, interpretation also can work in this way as well. With this interpretation, yeah, it suits with the definition. The rate that this guy willing to exchange, he said, it's fine to steal from him. Don't worry. But if you want to resume his happiness, please compensate back with 1 unit of good Y. He get back to the same utility level. Utility remain unchanged. Yes. One more time. He is at point B. We ask the same question. If we steal 1 unit of good X from him, how many of good Y he want to be compensated? This guy said 6. Yeah. Minus 1X must be compensated with 6Y so that utility will be resumed. I hope you understand now why we need this, such that utility remain the same. Stealing is okay, but if you want to make sure that his happiness is resumed, give him good Y until he said enough. If you give not only 4, then no. 5, no. 6, now he changed his face. Look the same now. Happiness resumed. Okay. All right. We use this idea when we compensate, when government want to compensate with people about the loss. Yeah. Okay. At the time that we start to build Suvarnabhumi airport, right? And many villagers suffer from the noise from the airplanes. Government has to compensate money to those villagers. And we use this idea when we ask them how much money do you need in order to compensate with the loss, loss of like a quiet or peace, because now they're going to live with the airplane noise, sound. Okay. All right. Now you understand the term MRS already. One more thing, marginal rate of substitution is not constant. Since the curve is downward sloping, MRS keep falling. MRS is diminishing. Is MRS it's diminishing for indifferent curve that shape look like above convex IC. Okay. The shape tells story how this person regard or look at pizza and Pepsi with convex IC. Slope change all the time. The rate that he want to trade one good for another good change for the time, depends on whether he is hungry or not, as you could already see. Then when it's convex, it implies that pizza and Pepsi are imperfect substitute. It's not always the case that if you steal one, you give him one, he is okay. No. He changed answer all the time. Yeah. Okay. Then it's implied that X and Y are not perfect substitutes, are imperfect substitute. If it's perfect, it has to be still one, compensate one, and he is okay. But this is not the case here. Here, X and Y are imperfect substitute. ทดแทนกันได้อย่างไม่สมบูรณ์ imperfect substitutes. Yeah. So now we start to see why economists use indifferent curve to describe preference. รสนิยม Yeah. So the preference for this person, he regard pizza and Pepsi as imperfect substitutes. How about perfect substitute? Then IC would not look like this. Let's take a look. If the two goods are perfect substitutes, how IC would look like? Let's check. As we know, indifferent curve is a tool to describe person preference. Oh. Okay. Maybe I just do it this way. Let's take a look. Yeah. Let's say good X X Coke, Y Pepsi. Suppose this guy will X and Y as perfect substitute 1-to-1. You may not feel the same like this guy, but this for him, he is indifferent between one can of Coke and one can of Pepsi. Both give the same satisfaction to him. Perfect substitute 1-to-1. Okay. Let's have the scale. Number of cans per week then in his refrigerator. Let's start with right now, basket A then. Basket A, it's about two Coke, no Pepsi. Now let's do this thought experiment. From A, if you steal one Coke from him and compensate with why he traveled to this point, and he said, thank you, I'm okay. Even though you take away one Coke, you compensate with one Pepsi, he is perfectly okay now. So we got this point B, 1-1. Yeah. One more time. You again steal one Coke from him. Now he got 0 Coke and crying. You compensate with Pepsi, 1 unit. He said, oh, thank you very much. I feel my happiness resume. So he come to point C, 0,2. And then we do this thought experiment with this guy. He already said, oh, he is okay. He is okay. When we steal and compensate enough, his happiness resumes. So CBA give the same satisfaction. So we write down, we draw an indifferent curve, connect these 3 points together. Yeah, this is a shape of indifferent curve when the person here view the 2 goods as perfect substitutes. And let's call this IC1. You can argue that on the IC1, the 3 baskets here are indifferent. We use this notation, yeah, which means that happiness from basket A, happiness from basket B, happiness from basket C are all the same level. Utility are all the same. And one more. When we sum the 2 amounts together on each basket, what does that mean then? 2 plus 0 equal to 2. 1 plus 1 equal to 2. 0 plus 2 equal to 2. Then this guy said, I don't care the label, whether Coke or Pepsi, as long as the total amount 2 units, he is perfectly fine. All of them are indifferent. He doesn't care about labels. Okay. Now, if we can have one like this, you can also have more. Like this. Maybe here. Oh, Sorry. Maybe I use another color. Let's have one more line. Yeah. Let's name it IC2. Even though we know that there are a lot more in between IC1 and IC2. Yeah. But now we just pick one to show more. Okay. Yeah. You can see D, E, F, G, H. Yeah. Basket D 4,0, 3,1, 2,2, 1,3. H is 0,4. Again, on IC2, all basket here, as long as total sum equal to 4 units, he is perfectly okay. Doesn't matter what combinations. D, E, F, G, H baskets give the same satisfaction level to him. Yeah. And the reason that I draw one more to argue that utility on IC2 must be higher than utility on IC1, as total sum of the two goods is higher than the basket on the pink IC. Yeah. The higher the indifferent curve towards northeast direction, utility level increase in utility level. You can see that if this guy is nice to you, if he start with basket B, you give him more of good vibes. Like this, he gets happier. Or you can give him more of X, he gets happier. Give 2 cans of Pepsi or 2 cans of Coke, he jump to the blue IC. Or you can give 1. Yeah. 1 Coke, 1 Pepsi, he also jump to IC, the blue one. Yeah. There are many ways to improve utility of this person. Yeah. If this person is your customer, yeah, you can think about several packages to generate the same happiness level to your clients. Yeah, like this. Yeah. Okay. All right. To summarize, indifferent curve for perfect substitutes, it's a straight line. And before we leave, what is MRS here then? Yes. Special case like this, MRS is constant. Not like above the convex IC. MRS always falling. Yeah. This case, delta y over delta x, it's 1 or minus 1. Okay. Perfect substitutes. From perfect substitutes, there is another perfect one. Perfect complement. Next picture. Perfect complement. Okay. Suppose this is a classic example to obtain indifferent curve for this case. Perfect complement. The two goods must be used together in a fixed proportion. Here, 1 left shoe plus 1 right shoe become a pair of shoe can walk. So fixed proportion here is 1 and 1. Okay. Another example that you can have is like one iPad and one Apple Pencil. Yeah. Also using a fixed proportion, 1 to 1. Or you can think of car. A car with 4 wheels. Perfect complements used together in a fixed proportion, 1 and 4, 1 and 4, 1 and 4. Yeah. But for motorcycles with 2 wheels, or one motorcycle with 2 wheels. Okay, let's see how the shape would look like in this case. X and Y. Okay. Suppose this person start with having one left and one right, one here. Okay, now he can walk with a pair of shoes. Point D. A pair of shoes. Okay. Now you have a pair of shoes. Yeah. What is your nickname? Bai Tơi. You are at point D now. Bai Tơi. What is your good friend next to you? What is your name? P-A-U. Pao. You are nice to her, right? You give her one more left shoes. In the picture, you move Bai Tơi to this spot. Since you give one more of good wine, one left shoes, good wine, change from 1 to 2. Bai Tơi, how do you feel about this gift? She give you one left. She is strange, right? Sorry? What did you say? No, I just asked about your feeling about this gift. She give you one more left shoes. Are you happier? No? She is quite strange, right? Gift like this. Okay, do one more then. If you are not happy, she said, okay, Bai Tơi, I give you another one. Now you have one right and 3 left. How do you feel? Happier? Now you already feel strange about this. Okay. He keep giving you good wine more, which is no use, right? It's no use. Extra wine that you received, there is no use. Then when I look at your face, I already see that it doesn't make any difference. The green basket, pink basket, red basket, give the same satisfaction to the original basket D. Yeah. So A, B, C, D generate the same satisfaction. Yeah. To make it useful, we should give person a fixed proportion, one more left, one more right, two more left, two more right. Giving only one Y doesn't make any difference to the original basket D. In similar manner, this way as well. E, F, G, H. Give all from basket D. Give only good X more. One more right, one more right, one more right. Doesn't improve utility of this person from basket D at all. When we confirm with this, now you are ready to write down the shape of indifferent curve. In this case, it's L shape. Yeah. IC1. L shape indifferent curve for perfect complement. Yeah. So yeah, if we want to improve by the utility level, we should give him like here, bring him to the dash basket, give one left, one right, and one left. Then she jump to this spot. And from this spot, you can argue again. You can create an indifferent curve here. Let's call IC2. So, yeah. So happiness on IC2, happiness level, it's higher than happiness level on the lower IC, like IC1, as usual. Yeah. Okay. That's a preference curve when the two products regard as perfect complement. Okay. All right. Finish. Any question? Okay, summary. Here, we put two extreme cases together in the one picture. Yeah, actually can put them separately, but we want to see something here. When you have a rope, you make it straight like this. Yeah, it's about perfect substitutes like Coke and Pepsi, straight line IC. But if you make the rope L shape, you get another extreme case, perfect complement like left shoes, right shoes. And the case that we usually study in this class is in between these two. When you make the rope convex like this, imperfect substitute, it's a case in between perfect, two extreme cases. X and Y are imperfect substitute. Orange one refer to the preference that X and Y are perfect complement, like left, right shoes. The black one, yeah, X and Y are rival products, are perfect complement, perfect substitute, sorry. Coke, Pepsi, it's an example for perfect substitutes. Right shoes, left shoes, perfect complement. Okay. Two more slides. We will say goodbye to the room number one. Room about preference, which we utilize in different curve to describe consumers' preference. Okay. Yes. Oh, thank you. Right shoe and left shoe. Thank you. Yeah. Ah, Okay. In real life, when we look at commodities, we can classify commodities into three types. A commodity like good X may be good, may be bad, maybe what we call neutral. If good X, it's good. If more of good X, it's preferred to less of good X. Yeah. Yeah, that's quite straightforward. A good, it's bad when less is preferred to more. Think about pollution. Think about grade F or grade D. Yeah. Less is preferred to more. Yeah. And the last one. Economists also think about something abstract, like if we talk about injustice in the society, less justice is more is preferred to less, of course. Yeah. Injustice, less is preferred to more. But justice, ความยุติธรรม เนี่ย more is preferred to less. Honesty, more is preferred to less. We would love to live in a society that people are honest. Yeah. Give the more satisfaction level to living in a society that less level of honesty or trust in the society. Third, when good X is neutral, that means having more or having less doesn't impact happiness. So suppose you feel quite neutral about like a jazz CD, jazz music. Maybe if your friend take away jazz CD from your shelf or give more, it doesn't impact your happiness level, for example. So, all right. Okay. Now, if two products, if X and Y are bad, can you describe shape of indifferent curve then if the two goods are bad? Yeah. Now, treat this as application. People ask you, since you already study indifferent curve for a while already, if you want to describe the taste of a person that regard the two goods here as bad, yeah. Maybe here like a garbage. Measuring in terms of, let's say, number of liters in front of your house, garbage. And yeah, less is preferred to more, of course, garbage. Another one, let's say noise pollution. Which can measure in terms of decibels. Yeah. The level of noise decibel. Yeah. What is your nickname? Moni? Moni? Which both less is referred to more, yeah? Less garbage is preferred to more garbage. Less level of noise is more preferred to high level of noise. Which basket of X and Y did you prefer the most? That's right. Here. No garbage at all. And quiet atmosphere. No disturbance. 0, 0. Yeah. Economists call this point as bliss point. The basket that generate the highest utility to this person, it's no X and no Y. Of course, then that means if you move towards this point, southwest, right? ตะวันตกเฉียงใต้ southwest, it would improve your utility. Then in different curve, if you draw, this is not PPC, yeah. The direction to improve utility, it's to move towards 0, 0. Let's name the IC. Yeah. Happiness level on IC4, the inner one, it's greater than the outer IC. Yeah. Being on IC4, it's nicer than being on IC3. Being on IC3, it's nicer than being on IC2, and so on and so forth. Let's check whether this makes sense or not. Suppose now you suffer from some amount of garbage and some level of noise. You are on IC1. If someone want to improve your well-being, this person can do the following. Can lower level of garbage. Yeah. You will jump to the higher IC, IC2, happier than being on IC1 when you are moving away from A to B. Reducing garbage, improve utility level of this person, or reducing noise. Also can improve happiness received by this person, or both, or doing this. Reduce amount of bad, either X or Y or both, can make this person become happier. Okay. All right. You can also think in this way too. If you say to this person that, hey, I have no authority to do anything with your garbage, but what I can do is to do something with the noise reduction. You can see, move this, reduce noise, given the same level of garbage. If we reduce the level of noisiness, it could make this person happier. And another way, if you said, oh, you are responsible for, what I can do something with garbage. I have authority to reduce garbage in front of your house. That's also improved utility level for this guy, even though you cannot do anything with the noise level. Yeah. Okay. All right. One last thing that I want to ask you to do by yourself is, if you play with the slope of this case, you realize that, hey, this case is different. Slope become steeper, 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 steeper. MRS is not diminishing. MRS is increasing. Why? Yeah. Okay. Apparently, it's increasing. And I'm going to ask you, you answer this by yourself. Does it make sense? Why? Can you explain why? Okay. All right. Perfect time before the break. One last case to take a look. Are you guys majoring in finance? Yes? Okay. Then this case is for you. Okay. We are going to apply this knowledge to portfolio investment. I'll finish. Okay. Okay. Now, another application for those study finance. We're going to make a connection between microeconomics and finance. Yeah. Microeconomics is a foundation of finance and behavioral finance. Yeah. We have in the world of X and Y, good X. When we look at a portfolio investor, he faced with two things when he invests in stock market: risk and return. 2 R's. Yeah. Risk, it's something bad, yeah. Less level of risk, it's preferred to more level of risk in the portfolio. We would expect to be happier if our returns has lower level of risk, less volatility, which measuring by standard deviation, yeah, how the combination of your stock, the level of volatility, yeah, ความผันผวนอย่างวุบวุบ bad as, oh, I should not write here. Move as less risk, it's more preferred to high risk, yeah. Less is preferred to more, yeah. Everyone agree with this. Return, yeah, it's considered as good as more level of return in terms of percentage return, it's more preferred than less percentage of expected return, yeah. As more is better, yeah. More it's preferred to less. More mean more of returns, yeah. So it's perfectly suited with this story about indifferent curve. We want to describe preference of an investor, and you know that การลงทุนมีความเสี่ยง right? Investment contains risk. Utility level, it's a combination of risk and return. If you are fund manager and your client, yeah, you understand the goal, yeah. Your clients, you want to maximize utility level of your clients, and in the portfolio it contains these two are, one is bad, one is good, and you have a clear idea already that if you reduce level of risk, your investor, you can make this person happier by having more return. The port generate higher return, yeah. Or you can do both. Reduce risk, make the return higher, that would be even better, yeah. Okay, so the basket of the two products, two goods here, contains one good and one bad, different from above, like Pepsi and pizza. Now the question is, if we want to describe the preference of this person by using indifferent curve theory, how does IC would look like? Okay, X is risk. Good Y, I call good, but it's not a good in the traditional definition yet. It's return. And we know that for risk, less is preferred to more. For return, more is preferred to less. Then first let's start with this idea, yeah. You want to stay away from risk. You have to keep escape from X. Having less X is good than having more X, but having more return, it's better than having less return. So draft idea is about, oh, if we talk about direction to improve utility, must escape from X towards Y. So must go like this. The wind must blow like this. And now let's talk about the shape of the curve then. Okay, let's introduce this shape there. How about this? Upward sloping indifferent curve. Let's check whether it would make sense or not. Just one to try to explore whether it makes sense if indifferent curve, it's upward sloping like this. I see one. Okay. It's easy to just check intuition by just have a thought experiment with this. Okay, let's make the picture ready to discuss then. And you know that usually speculative stocks give higher return than traditional stock. Yeah, high risk, high return. So now you want to have conversation with your client now. Let's start with portfolio A with some level of riskiness and some percentage of expected return from this port. So risk, as you know, we measure by using standard deviation. Yeah. Just use Excel to compute standard deviations of this mixture of the stock. Yeah. This stock give 10%, this stock get 30%, this stock give 5%, and we compute standard deviation of the portfolio by which representative of level of riskiness, yeah, volatility of the port. Yeah. Return percentage, yeah, percent return. Like this. Suppose you were a fund manager, you talk to this guy, your investor. You said, hey, Mr. I'm going to make your port become more riskier. Of course, he will say, oh, he said, okay, but please, he is okay to make his port become riskier by putting more speculative stocks in. But he said, make sure that I got compensated by a bit higher return. He willing to do so. If you want to adjust the port, make it more risky, but please compensate with some more return such that his utility will be resumed. You know already that if you only make the port become riskier, he will fall into the lower IC like this. There are thousands of indifferent curve in this. Yeah, if you make the port become riskier, you move him to this spot. Yeah, you must compensate back with some level of return, such that this guy is completely okay with this. Yeah. And now, if you do the same, hey, Mr. I want to put more speculative stock into the port, make the port become riskier. He said that, okay. But as his port already become very, very volatile, he said that to do so, please give enough compensation for this higher risk by making the port get a lot more return in compensation, so he will get back to the same level of utility. That's MRS. Yeah. So MRS is increasing in this case. Yeah. When risk is relatively low, it's okay to compensate with a little bit of return. But at high level of risk, the investor need a lot more compensation for the same level of increase in riskiness. Yeah, one unit. Yeah, this indifferent curve makes sense. And now you already know that to improve his happiness, the direction must go like this. Going towards higher return, keeping away from risk, as you could see immediately here. Like this. Look at this jump, yeah. If we fix return and we make the port become less riskier, this guy gets happier. He jumped to the higher different curve, this horizontal looking, given the same level of return. If level of riskiness reduced, happiness improved. If you want to look in terms of if you fix return, fix risk, and you make the port get a higher return, this guy also jump to the higher indifferent curve. Okay. So for risk and return here, I see it's upward sloping. MRS is increasing. Direction to improve utility, move to what? ตะวันตกเฉียงเหนือ northwest improve utility. Yeah. Okay, let's take a break then. We finished indifferent curve already.